Okay, last video I made, I viewed it and I noticed that I'd made a mistake figuring the concrete. I figured those piers to be 30 cubic feet. They were 30 square feet, or let's see, 3 times 3 is 9. 9 times 3/4 is 6, times 5 is 30 cubic feet for all 5 of those piers, which would be about a little over a yard. So I think I was about 4 yards long on that pour. If I would have ordered concrete at that rate. Now, if concrete is $108 a yard and you order 3 yards too much, that is $300. That's a big mistake. Now, we want to be efficient. So if you figure your concrete, figure it twice. Even have someone else to figure it with you, because chances are if you figure concrete wrong the first time, you'll make the same mistake when you figure it again. The second point about that is don't be in a hurry. Take your time. Be sure your figures are right. There's lots of places when we bid, when we figure our materials, it's so easy to make big mistakes, have lots of material left over. On the other end of the spectrum would be to not order enough. For example, concrete has generally, where I've ordered concrete before, they've had a 3-yard minimum. So if I order short and I have to order another half yard, it's going to cost me $300 for that half yard because I didn't order enough. So be careful. Order enough, but don't order too much. You want to have a spoonful or so left over, but you don't want to have 3 yards left over. Another thing about concrete pours, lots of times if you're with a customer that you're pouring concrete for somebody, I had it happen to me a few years ago on a pole barn. There's a little bit left in the truck and they've got to find something to do with that truck. If you're pouring a big floor and the customer wants to dispose of this, make use of this little spoonful of concrete that's left over, and you don't have enough help on the job to start with, and it takes part of your crew to take care of this little bit of concrete, it takes away from your main pour. That little bit of concrete is not important. What's important is your main pour. Order what you need, order enough, not too much. Be very careful. Now, we were talking about foundation wall, and we had determined the size of the concrete. Now, if this is a house that we're building, there's anchor bolts in this foundation wall, and generally speaking, you have to have, if you were looking at the corner of the foundation, looking down on the top of a foundation wall here, where you're going to lay the next component of your structure would be your sill plate, which fits right on top of this concrete wall, block wall, whatever you use. Specifications, well, code usually calls for an anchor bolt to be within 12 inches of the corner, and that is 12 inches both ways. So you need an anchor bolt within 12 inches here and within 12 inches here. And the code is you have to have an anchor bolt every 6 feet. That's the code where I'm at. It may vary. You need to check those things, because if you're in a place where you have an inspector coming out, he's going to look at your anchor bolts. Another thing that you've got to be careful about when you lay your sill plate on top of these foundation walls, this is elevation view, this is plan view. Plan view is looking down on top, elevation's looking at the edge. Actually, this would be a detail drawing here. This is Another thing about about your anchor bolts, you need to have an anchor bolt within a foot of the end of each of your joints as you lay this sill plate down. It's not very straight, but that's the idea. So within a foot. And the same thing here. Have to have anchor bolt within a foot, within a foot. Now, you don't lay your sill directly on the concrete. I use a styrofoam, what you call sill sealer, and it lays on your concrete before you place your sill. And these sills, you have to drill those holes for that sill. And the easiest way to do that is to square up, lay your, this is treated lumber. If this is an 8-inch block wall, I'd use a 2x8 on top of there, on top of my sill sealer, which goes against the concrete. I would lay it there, I'd square up, I'd hold it flush with the edge, and I'd hit it with the hammer to mark it. And you'd hit it at each bolt. That way it would fit exactly over where you place your bolts. Now the next component, I'm going to draw it a little bigger here. So you've got your concrete wall, you've got your sill sealer, which is just 1/8 of an inch thick. You've got your anchor bolts sticking up here high enough. These anchor bolts protrude down into the concrete. I use 16-inch by 1/2 inch for a regular house. They have a bend on the end, and you put a nut. Have to put a nut on there and a washer underneath it. Okay, so you've got your 2x8 sill on there. The next piece is your joist header, your box header. And generally, the houses I've built lately have been 26 feet wide, which is kind of our standard that we build. So we use 2x10 floor joists. Okay. Now, so we have our foundation wall, we have our footer under the foundation wall, we have our sill sealer, we have our treated lumber sill, and a regular number 2 framing lumber joist or box header. And then our joists, everything I've ever built has been 16-inch centers on whether it be 2x10s, 2x12s, and I've even seen 2x8s on a narrow span on that 2x10 or 2x8 or whatever it is. You need to look at a table to see what the load limit is for your particular kind of lumber. You can find charts to do that. Normally it will be specified within the specifications, or the architect will be there to tell you what it needs to be. Or you just, from experience, you know what it takes. Now, I'm going to draw again here. You've got your foundation walls, and you have piers out here in the middle of this thing sticking up. And generally, I like to put a piece of treated lumber on top of my piers, and you would have a girder. Now, girders depends again on your span. According to the building codes where I'm at right now, we use a 2x8 girder. We have to have 4 pieces of 2x8 nailed across. Naturally, we put the splice, we get 16-foot pieces. We have our piers on 8-foot centers. So when we put our girder on top of the pier, any joint will be centered on top of this pier. And we stagger our joints. If we have 16 footers and our joints, our piers are on 8 foot, our lumber is 16 feet long. One piece would go from here to here. The next piece would go from here to here. So with 4 joints staggered, then looking down on the top of that particular beam, say we had let's call it a 24-foot length. This would be one pier here, one pier here, one pier here. This is underneath. The first layer would break on this pier. The next layer would break on this pier and this pier. This one would go past to the next. So what I'm telling you, you stagger your joints. Okay? One joint will be here, the next joint here, the next joint here, the next joint here. 16-foot lengths. And they set in a beam pocket where they meet the outer wall. Okay, here's your outer wall. You would make a beam pocket in that wall, place your girder. Now, when you place your joists on top of this foundation, they always have to lap. They come up, they fasten together here in the middle, okay? One would be back there, they lap. Looking down on plan view, you have your box header, you have your joists, okay? Here's your pier in the middle. So one set's on this side of the line, the other set's, well, it would come out here. Let's make it come out here. So that's your configuration right there. Now what I do when I lay out my, okay, here's your box header sitting on top of your sill. I would come out here on top of my girder and inside of my rough drawing. I would come from the end here. I would come 15 1/4 inches, and I would make a line here, here, and here. This joist I would put on this side of the line, and this joist, no, that's not what I would do. I'd put, here's what I do. Yeah. 15 1/4 away from the end. We've made our line all the way across at 15 1/4. So when you get out here to 8 foot, you got your joist sitting here on 16-inch centers. After you come to the 15 1/4, you go 16 inches from the center of that one to the center of this one. When you get to 8 foot, your OSB, plywood, whatever hitting, would hit right on the middle. So you'd have joists like this coming to 8 foot would be your center. Over here, your 8 foot would hang over 3/4 of an inch to saw off. and when you got out here to the center, it would work all the way down. The next thing, about 3 houses ago that I built, the inspector came out and he asked me, he said, why did you put bridging in there? I said, well, that's what we've always done. He said, the code no longer requires bridging. Well, the code might not require bridging, but I require bridging. What you do with bridging, I'm getting my blackboard full here, I can see. So you have your joists. So we were talking about the bridging. This is what you call tension bridging. They're metal. They go between your joists, looking at the end of your joists. And what bridging does, if you step on this joist, it spreads the load out to this joist and this joist. Spreads the load over your floor. So anytime you have, let's look at the plan view again. Here's plan, here's looking in the side of it. Anytime you have an opening, stairway or a crawl space access, I always double the joists on both sides of this. Now, I'm sure some people don't, but I like to double the joists anywhere I have an opening that's bigger than, if I have to cut a joist to put the opening in, I will double the joist on the other side of the opening. And I double the joist headers where I head that off. Years ago, when I first started, I would even put a joist, say I had a partition above, I would put a joist on each side of my partition so that you had a wall on top of the floor. This is your stud, this is your bottom plate, this is your flooring. When you got underneath, I would have a joist under both sides of that. That would allow for heating ducts, plumbing, whatever, to go up through the wall. It wouldn't interfere with the wall, but you would have support on both sides of the joist. Now, it's important to have these floors to be strong enough that when you walk across it, you're not having sway, you're not having rubbery, bouncy feelings. It's got to be right. Whatever you build is permanent. People are going to be living there. If it's not right, they're going to complain. Your reputation will be bad, and your work will dwindle. You won't have work anymore. So do it right. And that's my lesson for today. Floor framing. I'll include a couple pictures. Have a great day. Thank you.